Next attack is web is weak against replay attacks. If attacker captures one packet and replays that packet on the wireless network again and again, if say that packet is say ARP request sent by the client, then when attacker replays that packet on wireless side, the same ARP request will go again and again. The other side machine for which the ARP request is sent will respond with ARP reply, and for free we will be able to generate lots of packets, and there is no protection for against these replay attacks in web. Second is fragmentation attacks. Now with all these above attacks, if we know some part of the key stream for a particular initialization vector, it is very easy to find out key stream for a particular initialization vector. So by some means, if we get a key stream for an initialization vector, then we can transmit any packet because there is fragmentation method. If we know say first 20 bits of the key stream, then we can fragment the packet, each packet being 20 bytes. And since we know 20 bytes of the key stream, we can actually generate a legitimate packet for 20 bits, and if we use the fragmentation at the receiver end, he will again able to join all these fragments together to create a complete packet. Then known plain text attacks, known plain text replay attacks are also possible. Likewise, I said ARP request frame. So most of the things in ARP request are known. ARP is having fixed length, so it is very easy to find out which is the ARP packet in AP client communication, access point client communication. It is easy to find out the ARP packets. Even if they are encrypted, they are a fixed size and they are generally broadcast packets, and with all these things we can find out which is the ARP packet. Now inside ARP packet, most of the contents are fixed, so that much amount of key stream is now known to you. Now if you are able to disassociate that client again and again, it is even more better for you, because that client will send gratuitous ARP when after immediately reconnecting to the subnet. Likewise, many attacks are possible. Then shared key authentication, if used with web, it is the worst thing that administrator can configure, because in shared key authentication protocol, the challenge response method is used. AP sends a 128 byte challenge text to the client. Client encrypts that challenge text with the same web procedure, that is IV is there, key stream is there, key is there, find a key stream and XOR it. Now in this process, the 128 byte challenge is clear text. You know the response to that challenge as well, which is encrypted. So the key stream for these 128 byte for this particular IV are very well known. And likewise, believe me, there are lots of attacks. I have tried to mention few of them. Now let's see the in broad sense types of attacks. IV reuse attacks, as I said, if IV repeats again and again, it is very easy to find out the key stream. Second attacks I discussed about were replay attacks, replaying same packet again and again on the network and waiting for the response for that replayed packet. Third type of attacks are statistical attacks. Now if lots of packets are seen on the air, statistically we can find out what the content of that packet will be with lots of key streams, and some statistical models can be easily created. Then next thing is IP modification. Now in IP modification, the IP address location in the packet is fixed. So if we are able to modify this IP address with simple bit flipping or if in any other ways, we can even generate lots of more packets. Next attack possible is active attack to inject traffic. Actively we can inject the traffic. If we know key stream for a particular IV, we can actually create a packet and we can inject it actively on the wireless side. Next attack I discussed about were the bit flipping attacks, in which a few bits in the packets are flipped and ICV value was recalculated. Natural question that will come to anyone's mind is, okay, there are so many attacks possible, agreed, but can I generate the attack? Can I crack the web key? And the answer is yes, a big yes. There are lots of tools, lots and lots of freeware, lots and lots of open source tools available to generate all such kinds of attacks. But you name it and the tool is there. Bit flipping is there, replay attack is there, active injection is there, and all sorts of attack tools are available. Few example tools are AirSnort, which will generate FMS and Corec attacks. Then AirCrackNG is there. It again implements FMS, Corec, replay, and many other attacks. There is one very interesting tool which is AirCrack PTW. It actually uses the R packet based attacks. Now in R packet, lots of fields in R packet are very well known. So for any IV, for this AirCrack PTW to run, the IV need not be a weak IV. For any IV, since most of the things in R packet are known, it is very easy to launch an attack on R packet. The other tool is WebLab. There is AirReplayNG. AirReplayNG comes with many tools actually. There are specifically bit flipping attacks is possible with AirReplayNG, or replay attacks is also possible with AirReplayNG. There is other tool like WebCrack. And if you search on internet, if you search on Google, you will be able to find out many other tools. AirCrackNG is even available for Windows as well, and you just search it and you will get many tools on cracking the web keys. That's it for this video on web. We have discussed how web works and what are the main vulnerabilities in web and which tools can be used to crack the web keys. Feel free to browse other securitytube.net videos on wired and wireless networking. Thank you.